so much for taking time out of your day, because I know that days at the moment are precious and they're still not really working normally for most of us. So we are super grateful for you sharing your time with all of us as a group. So this is the first kick-off event for this Rise of the Resistance family. It's kind of like a family. Rise of the Resistance Festival, which is all part of a bigger piece of work called Project Nosocomial. We're super excited for you to come and join our world and start our conversation, which is what Project Nosocomial is all about. So the first conversation we're having today is about what is AMR and what does it mean for all of us. So I'm going to hand you over to our wonderful artisan scientists. Thank you very much.
What is antimicrobial resistance? What is antimicrobial? Is antimicrobial the same as antibiotic? What even is antibiotic? Do any of you know? Well, some of you act like you do, but you're really thinking about something else.
On 3rd of September 1928, Dr. Alexander Fleming returned to his laboratory at St. Mary's Hospital in Paddington after a holiday and said,
"That's funny." Before he left, Fleming had inoculated staphylococci on culture plates and left them on his workbench. On return, one was contaminated with fungus.
The colonies of staphylococci surrounding it had been destroyed by the antibiotic effect of penicillin.
Dr. Fleming's lab, St. Alex's Hospital, Paddington, 1928. Alexander Fleming stands in the doorway to his lab, staring at the cluttered bench.
In summer 1928, I was promoted, Professor of Bacteriology. Same lab, same work. Theoretically, longer holidays. I packed up my golf clubs and left for August in Suffolk with Sarah and wee Ralph. A month of egg and spoon races, cricket on the beach. I grew up in a big family, surrounded by hills and sky. I wasn't ready to come back. When I woke just after dawn on Monday the 3rd of September 1928, I certainly didn't plan to revolutionise all of medicine by discovering the world's first antibiotic or bacteria killer. But I guess that was exactly what I did. A month in the country, morning walks, watching the textures of grass moving under my footsteps, hearing only breathing and the wind. I don't know. My wife Sarah was a nurse. Faced with dust and teacups and stacked petri dishes, she'd sweep the whole lot into the boiling suds. I felt something, noticed something. The side window, a crooked latch, rain or damp air. A petri dish, like a teacup, left too long, and a pot of jam. An island of mould, big as a penny, and around the mould, beautiful as a seashell, perfect as a rainbow. Nothing. A zone of inhibition. Something in the mould growing on the culture medium, had inhibited the bacteria. Was in fact inhibiting their cell division, but all I knew was it was beautiful to me. A natural substance of unknown origin growing that could hold bugs back. Penicillin. Penicillin, grown from penicillium. As simple as that.
Excuse me, what's happening? What are you lot doing here?
I've come from UCL today.
I'm coming from University College London Hospitals.
I'm from Department of Chemical Engineering, University College London.
And I'm from Great Ormond Street Hospital.
Welfare Hospital, University College London.
Oh, I'm just here testing the survey.
Why are you here?
So I'm looking at how AMR bacteria transmits between different groups of people in a rural community in Kenya.
I'm searching genomic characterization of Pseudomonas aeruginosa strains found in hospital shower water and in patient bacteremia isolates.
Characterisation of the gut and urinary microbiome for predicting treatment-resistant urinary tract infection and its downstream complications in renal transplant recipients.
I'm examining gold nanoparticles decorated on stimuli-responsive polymer brushes as a stable antimicrobial surfaces.
Alright, so I get penicillin was the first antibiotic, but what is AMR?
So it's basically when bacteria evades antibiotic therapies and the drug stops working against that bacteria.
It's about microorganisms acquiring antimicrobial resistance.
So AMR is when microbes undergo genetic changes, so it causes them to become impervious to the drugs that it usually used to stop them developing. AMR becomes a problem when us humans don't use antibiotics wisely and responsibly.
Really, I'm just here testing the survey.
Antimicrobial resistance, AMR, is a serious threat, and it happens when microorganisms such as bacteria, viruses, fungi, and parasites does not respond to antibiotics.
AMR is where bacteria, viruses, parasites and fungi adapt and change over time, leading to their ability to survive and even grow in the presence of antimicrobials.
What does that mean to you? To us?
By the year 2050, more than 10 million people may die each year as a result of reduced drug efficacy. Since the discovery of penicillin in 1928, we can now successfully treat common illnesses with a few pills. Small wounds will no longer kill a person if they become infected, and childbirth is much safer.
AMR is where bacteria, virus, parasites and fungi adapt and change over time, leading to their ability to survive and even grow in the presence of antimicrobials.
AMR seriously threatens the huge medical advances we've made in the last 100 years, and we may soon find ourselves in an era where trivial illnesses may, once again, kill us easily.
To me, it means an uncertain future for my family and friends and future generations.
To me, the AMR crisis represents a human tragedy on an epic scale. Antibiotics were nothing short of a miracle when they were first developed in the 1920s, but despite nearly a century of dire warnings about what might happen, we as a species have just squandered these priceless weapons. If we don't come up with new solutions and we don't do a better job of protecting them, bacteria may soon kill us as easily as they did before we discovered antibiotics in the first place. And nobody wants to go back to that.
Another hospital, London, the present day. Eleanor, a healthcare scientist, arrives at a ward where Alex Fisher sits in bed, flicking irritably through a copy of the Metro. Alex had not expected to be readmitted today.
Mr. Fisher? Hi, I'm Eleanor. May I call you Alex?
Call me anything you like. I'm not going to get up and walk out.
Alex, I'm a healthcare scientist, and I'm here because the test on your knee showed a positive result for infection.
This is second time.
Your surgeon, Mrs. Ahmet, told me your knee replacement has already been taken out once as a result of infection.
She should have fitted me damn knee with a zip. Look, aren't you going to examine it?
I am. We're running tests on your joint fluid in the lab right now.
Let's see.
I wanted to find out a bit more about you.
Why? Have you lost me notes?
I know the ins and outs of your knee. Very little about Alex.
I'm a fitness instructor. The thing is, I think they messed up on my knee surgery in the first place.
There's nothing in your notes to suggest that.
But how can this be happening again? I take care of myself, exercise. I've only just got back from working on a cruise to Australia. I need to work.
The history of any patient is part of our shared biological history. Humans co-evolved with trillions of microbes that inhabit our bodies in complex ecosystems, constantly adapting to the changing conditions of their host. Us, me, you. Over 400 species in your gut alone. And without bacteria, our bodies will not function. As long as we are unhurt, healthy, bacteria can cause us no harm. before penicillin, any laceration or abrasion could be fatal. Like surgery, like Alex's, unthinkable. It's easy to look back and see penicillin as a turning on a switch, like hooray, infection control. I used to be called into one case of antibiotic resistance every 6 months, then once a month, to a week, and so it goes on. The fluid sample from Alex's knee is resisting antibiotics already prescribed. Initial tests suggest that bacterial infection is enteric, to do with the guts. Alex has recently been to Australia on a cruise ship, swims in public pools. Young microbiologists don't always understand why patient history is so important. Why waste time taking notes from patients when you could be concentrating on the science? I tell them patient history matters. It makes you think creatively outside of science. And the truth is, I need them to keep patient history front and centre because this is a person. It's Alex. When we're in the lab, we're working on Alex's life.
Alright then, what question do you wish someone would ask about AMR?
Why does AMR matter to me? There are plenty of other drugs I can take instead at the moment if one doesn't work.
What's the importance of AMR in clinical infections?
Number 1, what risks are associated with AMR? Number 2, how can we tackle the issue of AMR at all the scales? And number 3, how can general public help?
People quite often think that humans themselves become resistant to antibiotics. I hear this quite a lot. But I like it when people ask me about this because I can help them to appreciate that AMR is something that happens to the bacteria, not to the patient. And these resistant bacteria can spread from one person to another. If you grasp this, you'll see that it's a problem that's much larger than the individual.
So how can you help us, help me, understand?
With real life examples within their context. So someone will go to a doctor, they'll have their own infection issues such as a chest infection. They're prescribed antibiotics, they don't improve and they could potentially get worse.
Like a rising flood.
So basically, antimicrobial resistance happens when bacteria develop or acquire ways which stop them from killing the bacteria or from controlling the growth. So bacteria are actually very clever. They remember, they learn. If you don't kill all of the bacteria, the ones that will remain will develop resistance. And the way in which that evasion mechanism happens, they can then pass that to daughter bacteria. So when they divide, when they multiply again, they can pass that information to those bacteria as well. And they do this by small messengers called plasmids, which can be shared between not only your own bacteria, but bacteria from other people as well.
Casting call out. They're looking for actors for a show about antimicrobial something?
One doesn't need a microphone if one is classically trained.
You'll be alright, I've worked with them before.
I'll see you there.
So anyway, if you try enough antibiotics over your lifetime, you'll actually end up in a situation where no antibiotics will treat any of your infections anymore. And that's called PAM resistance.
This means that if you ever require routine surgery, it will be very hard to stop you from getting a life-threatening infection or recover.
It also means that if you cut your finger and it becomes infected, there is no way to treat you.
We need to explain how unhelpful the majority of antibiotics are in treating simple infections.
AMR is like an extra defense shield that bacteria can throw up against drugs. The bug itself is largely unchanged, but it often acquires something special that can render the drugs useless. So if you imagine the cell wall of a bacteria being an actual brick wall that needs to be constantly mortared and repaired to keep the bug safe as it grows, then penicillin comes in and prevents that mortaring. So the bacteria eventually explodes. If the bug becomes resistant to penicillin, it can produce a pair of molecular scissors that clip the penicillin into a floppy, useless structure that can't stop the bacteria from repairing its wall.
According to the latest WHO report, at least 700,000 people die each year due to the drug-resistant diseases. And this could cause 10 million deaths each year by 2050 if no actions are taken.
Meanwhile, back at the hospital, our friend Alex is waiting for his test results, and they're all clear to go back to work.
Hello, Alex.
Hey, Doc.
I'm a healthcare scientist and a doctor by PhD.
Have you got my results?
I've got an initial result on the type of bacteria.
What's that? Good news?
It's good in the sense that I can prescribe you a broad spectrum antibiotic aimed at containing the infection. As soon as we isolate the bacteria, we can hone treatment, and then I can change your prescription again.
Whoa. Why do you keep changing it? Why can't you find the right one?
Because the bacteria in your knee are resistant to the antibiotics we'd normally use.
Since when?
We'll know more in the next 24 hours, whether it's a bug you picked up recently or an existing bug that's become resistant.
How? Listen, I never take antibiotics, hardly. For a chest infection from a GP like anybody. I had a tooth out and yeah, after I broke my wrist, I was on antibiotics, so about 3 or 4 times, and I always finished the course. Isn't there any chance you've made a mistake? I'm sure I'm not antibiotic resistant.
No, you're not.
I thought you said that I were.
Antibiotic or antimicrobial resistance is not something that happens to Alex or Eleanor. It is happening to the bacteria inside Alex or Eleanor. Some bacteria that colonize our body, our environment, have become resistant to the antibiotics we have to treat them, so that when Alex or Eleanor needs treatment, it's not there.
That's what antibiotic resistance is.
A particular bacteria has evolved resistance to the drugs that we use to treat it, not you.
What about my knee operation?
It's not safe. Not until we have a way to bring the infection under control, and even then...
I'm a fitness instructor. Supposing you can't control the infection, what then? Am I going to lose my leg?
Alex, I can't sit here and tell you that that's impossible. More likely you may require a clean and scrape to your joint.
Oh, God.
I promise you this. I and my team were doing all we can, and I'll always be straight with you, Alex. And I'm optimistic at the moment.
But I've always... I just came back in for a swollen knee.
With antimicrobial resistant bacteria increasingly common, the truth, I'm afraid, is that most of it's just very bad luck.
Bad luck?
I'm sorry that you have to face this. Are there any other questions that you want to ask?
Tar, for being honest, you're the first person who's explained that to me.
So that's your solution? Talking to people and being honest?
What's wrong with that? I like to have things properly explained. That's why people end up on the internet scrolling for clues.
I've been doing research too. I'm learning from experts all the time.
So inappropriate prescription of antimicrobials and easy access to them in lower and middle income countries increases rates of AMR. If you buy a drug without an informed diagnosis by a healthcare professional, there's a high chance of clinical failure. So because of this...
The wrong drug is chosen for the infection. Too much drug is taken over a long period of time or not enough. Where a patient feels better for a short time and stops taking their drugs, this can lead to a rebound infection, where the remaining bacteria that were not killed multiply until the infection returns. They may have learned how to combat the drug you were taking, leading to resistance.
Wow, you have learned a lot.
Microorganisms have an innate ability to learn resistance genes, sort of like an innate talent.
It's all very well to talk about using antibiotics wisely as a species, but on the individual level, that's not always so easy. I work with doctors who see elderly patients with urinary tract infections, which often comes in a low-grade form or which takes a slightly longer course to cure, and these patients may be incorrectly denied antibiotics in the name of stewardship. Equally, if you've got a baby who's very ill, as a mum, you'd rather risk making AMR worse for everyone than waiting 48 hours for a test to know whether or not your baby needs antibiotics to survive. Because for you, it's a precious life on the line right now, not a future abstract peril somewhere down the road. The solution would be better, rapid diagnostic tests so no patients who truly need antibiotics are denied them.
This is my house. Me and my husband bought it 8 years ago, and I haven't lived here for nearly 7 months. An A&E visit, that turned into a 6-week hospital stay, that turned into a 6-month hospital stay. I call my husband. Hiya, yeah, it's me. Yeah, I'm just back at the house because... Oh, no, she's fine, everything's okay. He thinks that something's happened to her. Every unscheduled phone call from me plunges him into panic, and I can sense the fear in his voice. I just thought I'd come back, and get some fresh clothes and pick up Fredbear, because she's been going about Fredbear all week, and I just thought that I would... Well, no, she had a 2-hour session booked in with the play therapist, so I just thought... Well, she's not on her own, is she? She's been in there for over 7 months. She sees a play therapist every week. She knows who she is. But I'm scared too. I'm hurt. I'm hurt that it's always about her. And I'm ashamed that I feel that way. That I'm selfish and that I don't exist. But I can't tell him that. So I defend my decision to return to what was once my home, to touch the things that were once my belongings, to live the life that I once lived, and to feel like myself. Yeah, well, you don't always bring the right stuff, do you? I've been wearing the same goddamn hoodie for 3 weeks. And I want him to say that it's okay, that leaving our sick daughter for an hour is okay. But he doesn't. And I hate myself for leaving her there. But I can't tell him that. So I deflect the conversation. So, what's going on with the living room, anyway? Oh, the wallpaper's been ripped off, there's gaping holes everywhere, what are you doing? Oh, right, so it's just been like that for another year then, is it? Yeah, okay. And yeah, you've been letting the dog on the bed? Yeah, and the fridge is full of junk. I mean, in fairness to me, the living room does look like a crack den. Having the dog on the bed really isn't hygienic. Eating crap really won't make you feel better. But none of that matters. I will go back. Just 10 more minutes.
She'll let me in a minute. I clicked on the link on time, but that's what they're like, isn't it? Students got to tear themselves away from the socials. Watching blockbusters, that was supposed to be the thief of time when I was a student. I didn't watch it. I thought he was a bit creepy, that bloke, Bob. So I might be doing her a disservice. She could just be late. She could think that watching cat videos is a bit creepy. Quite nervous about this, really. I don't normally talk about it much. I mean, who wants to talk about being ill all the time, on and on? Well, some people do, don't they? Even people who haven't been ill. I've got one of those give me money for something I want to do anyway requests on Facebook the other day. This woman that I worked with ages ago, she's shaving her head to raise money for Macmillan Cancer. And all these people are going, oh babe, that's so amazing, so brave, all that crap in the comments underneath. And I just thought, How dare you? How dare you? You're going to shave your head from choice, and everyone will go, oh, have you got cancer, babe? And you can say, no, I've just done it to raise money for the poor, ill people. I'm fine, really. Cancer tourism. I thought it was disgusting. I quite like her as well. If she wasn't my niece, I wouldn't be doing this. It's for a life writing module at uni. She'd probably say, you're just scared of being triggered, Auntie Jen. Because if they bring something into class to work on, they've got to do a trigger warning. And it's all about abuse and stuff like that. It's not on the list. She sent it to me, actually. I've got it in here somewhere. Yeah, so, I mean, it's all quite sensible, really. It's like misogynistic language and violence against women, rape, sexual assault, I mean, you know, all that. But then at the bottom over here, where is it? It's down here. After fat-phobic content, illness and death. Illness and death. One half of the world can't stop going on about it, and the other half have to warn you before they even mention it. I'd have liked a trigger warning for the pandemic. I couldn't work it out at first, like why it felt so weird. I mean, obviously, you know, it was pretty rubbish, wasn't it? But in a way, it was quite exciting as well, wasn't it? Like we're all getting to live through this really massive thing. It's happening in our lifetimes. Well, hopefully, we're gonna live through it. But I kept having these. Well, I suppose they were flashbacks, really, to when I was ill. I usually try not to think about it. It happened to me. I got over it, and it's done. But last year with the virus, I couldn't stop thinking about it because it was the same. The precautions were the same as when you're immunocompromised by the chemo. I was lucky. I didn't get an infection until I was on my 5th cycle, and the nurses said to me, so what antibiotics have you been on before? And I said, what before? And they said, when you've had an infection before. And I said, I haven't had an infection before, this is the first. And they said, oh, you're lucky, getting this far without an infection. You feel about as unlucky as it's possible to get. At the time, everyone was really amazed that I was in isolation for 5 whole days. And I mean, now that's nothing, is it? People have to stay in their bedrooms for double that. So, yeah, that bit of illness glory is denied me. I sing in a choir. One of the blokes is a doctor. He sent me this email when he knew what I'd got, and he said, the prognosis is very good if you get through the treatment. If you get through the treatment. I don't really know what he meant, and I just wrote it off as usual doctor stuff, you know, let's look at the evidence here, which generally means let's be totally unsympathetic and controlling, but that is what he meant. He meant the prognosis is good if you're lucky enough to survive the infections you're almost certainly going to get. My oncologist said to me, it's really much easier if people do everything we tell them to, and I'm sure it is for them. Anyway, I did do everything they told me to. Because they said, the controlling ones, that they were treating to cure, which was obviously lucky, but you're still frightened. You're frightened all the time. Just have to distract yourself, which is handy because having cancer is pretty distracting. Like the whole business of it is incredibly time consuming. I was sort of relieved to get that infection because I could just stop being in charge of it, me, the cancer. They could do it all. It was actually quite relaxing to begin with. It never crossed my mind that the antibiotics wouldn't work. I mean, you just think, oh right, I've got a bit of an infection, so the drugs will clear it up. And then they say, so your sepsis, you think, what? Sepsis? My sepsis? That's like blood poisoning, isn't it? People die from that, don't they? One night, the nurse kept coming into my room at different times and said, can I do your obs now because we've got a bit of a crisis next door, someone's not doing very well. And I said, yeah, fine, whatever. I mean, it wasn't fine because she kept waking me up, but you know, when someone isn't doing very well next door to you, you do feel a little bit churlish, objecting. So I saw the fire. the tower, because I was on the 17th floor in my air-conditioned room. Safe. It was boiling hot that week, so I was lucky, everyone said, to be in the cool. Lucky. Oh, she's here.
I think I've got it. Now I think I understand. In fact, the truth is, now I understand it better than a lot of you. Behind your walls that need repairing, your leaky dams, you talk about the last line of defence. The news proclaims the war against infection. So, you think you're in a war against bacteria, do you? A war against resistance. That makes it a war against you, against people. And if so, people aren't winning. Every year you fight harder. More and more of you rely on drugs, last resort on surgery. Surgery now is needed for things a pill cured 10 years ago. Now you're scared that we're taken over. Bacteria at your service. Does it surprise you that I have a human face? I've grown inside and been with you all the time. You've heard me say it often enough. I like to learn. I learn from you. If there is a war, you humans started it. We were on your side. A microbial army of students and assistants ready to help out. Help digest your food, make your cheese, your bread, your beer. We rotted compost. We made soil fertile and crops grow. Bacteria took away your sick, your old, cleaned the natural world with decay and death. Until modern humans got greedy. You wanted to change the rules between us. All we do is follow orders. All we want is the same as you. To survive. We learn from you. We always will. We're greedy too. We follow your lead.
In 1945, Alexander Fleming accepted that year's Nobel Prize for his part in the discovery of penicillin. In Stockholm, Sweden, he steps up to the podium and gives this speech.
I'm going to tell you about the early days of penicillin, for this is part of the penicillin story which earned me this Nobel Award. To my generation of bacteriologists, the inhibition of one microbe by another was commonplace. Indeed, it is seldom that an observant clinical bacteriologist can pass a week without seeing, in the course of his ordinary work, very definite instances of bacterial antagonism. It seems likely that this fact that bacterial antagonisms were so common hindered rather than helped the initiation of the study of antibiotics as we know it today. I might have claimed that I had come to the conclusion, as a result of serious study of the literature and deep thought, that valuable antibacterial substances were made by molds and that I set out to investigate the problem. That would have been untrue, and I prefer to tell the truth. Penicillin started as a chance observation. My only merit is that I didn't neglect the observation and that I pursued the subject as a bacteriologist. My publication in 1929 was the starting point of the work of others who developed penicillin, especially in the chemical field.
Etc., etc., etc. And he went on to say,
penicillin may be changed by the chemist so that all its disadvantages may be removed and a newer and better derivative may be produced.
I would like to sound one note of warning. He said, it is not difficult to make microbes resistant to penicillin in the laboratory by exposing them to concentrations not sufficient to kill them. And the same thing has happened in the body. The time may come when penicillin can be bought by anyone in the shops, Then there is a danger that the ignorant man may easily underdose himself and, by exposing his microbes to non-lethal quantities of the drug, make them resistant. Here is a hypothetical illustration. Mr. X has a sore throat. Mr. X buys some penicillin and gives himself not enough to kill the streptococci, but enough to educate them to resist penicillin. He then infects his wife.
Mrs. X gets pneumonia and is treated with penicillin. As the streptococci are now resistant to penicillin, the treatment fails. Mrs. X dies.
Who is primarily responsible for Mrs. X's death? Why Mr. X, whose negligent use of penicillin changed the nature of the microbe. Moral: if you use penicillin, use enough. Okay, now we know what AMR is. What are we going to do about it?
So, hi, my name is Sam, and I'm a first year PhD student, and I'm based here at UCL, where I spend most of my time over at Great Ormond Street Hospital. And what I'm doing is I'm collecting samples from the environment around patients and in their waiting areas, etc. And I'm looking for bacteria, viruses and fungi that can cause disease. And the idea of this is to build a good evidence base that we can then put to the infection control and then use it as a way to prevent people getting the infections before they do, and then we need to prescribe antibiotics. So what led me to this rather specific and niche bit of science? So I think it's fair to say that I was always quite interested in living things and biology. I remember, even when I was like 10, being one of those kids who'd look under logs to find the insects and look in rock pools. And I feel like that then made me really passionate about the subject. And then in secondary school, we had this one biology teacher, and I just remember his lessons really captured my imagination. There was something about them that made me think, yes, I like this, I want to do this. So naturally for me, I was like, oh, I'll do it at university then, why not? And then, however, when I was doing my A-levels, they could have gone better, let's say. And I didn't get into my first choice of university, and I didn't get into my second choice of university either, so that was a bit of a setback. So I had to go through the clearing process, where you kind of look about and find a spot on a course. And it did knock my confidence, I will be honest. I was kind of thinking, am I clever enough for this? Can I do this? But looking back on it now, I think that was probably the best thing that could have happened to me, because I ended up going to a university that had such a strong focus on biology, and the biology that it did was really applied. It was all kind of, how do we use this in a setting that matters? So they did microbiology, and it was quite clinical. It was cancer, and then how was that related to patients? And I found that there was one microbiology lecturer there, Dr. Worthington, and there was just, his lectures, they, again, like my secondary school biology teacher, they really captured my imagination. And I was just like, yes, this is great, I was really enjoying it, and an opportunity came along to do a year placement in his research lab. And it was looking at a bacteria called Clostridium difficile, which is associated with infections, usually in elderly patients, and could be really quite serious. And it was doing that placement where I realised not only do I really like this subject, kind of from a reading and learning about it point of view, actually doing it, being involved, being in the lab there was what I wanted to do. So yes, I'm going to follow this. This is something that I am really passionate about. And over time I learned more and more about the topic of antimicrobial resistance and how that relates directly to the application of what I'm passionate about, microbiology, to patients. And it was through various projects, such as an antimicrobial awareness week that was run, where we would do events where we would show other students and primary school and secondary school pupils kind of what bacteria, and then how did that relate to antibiotic resistance? Why is it important? What does it mean? So here I am now. The project I'm doing at the moment, the aim is that we will find in the environment the bacteria that cause these infections, like your MRSA, and hopefully this research is going to be able to directly influence infection control and mean that patients won't get the infections in the first place, so cutting down on that antibiotic usage that we have. And it's it's that direct application, that ability to take this science that I'm really passionate about and get that research and directly improve patient experience and ultimately help with patients' survival that really keeps me going. And I think it's really important and just great to be a part of something that helps with this very serious problem.
So, it's important that just as there is a natural tendency for bacteria to change and learn, that people are learning too. What was it you said? The solution would be better rapid diagnostic tests so that no patients who truly need antibiotics are denied. The more ways we can intervene in our relationship to bacteria.
It's not war we need, but negotiation.
Imagination.
Teamwork.
We need to learn and talk about what we are learning and what is difficult for us.
We need to think globally. We need to learn from bacteria about cooperation, communication, teamwork. We need to support one another as a species, to share knowledge, discover where and how we make the right choices for our species and ourselves.
So imagine you are sick and you go to the hospital to get cured from your illness, but in the end you end up having an infection called an hospital-acquired infection. Just the same way, imagine taking a shower during your hospital stay and then you get infected by a bug called Pseudomonas aeruginosa. This bug is one of the most prevalent microorganisms in the hospital environment, especially in hospital water systems. It can infect your wounds, respiratory system, urinary tract, and from there it can pass to your blood. Here you see how we collect it from shower waters and drains. In culture microbiology, we see it in many forms and colors, as you see on left-hand side, green and yellow mainly. This bug is important because it has innate antimicrobial resistance properties and it can easily acquire it from the environment or from other species. On the right-hand side, we see antibiotic susceptibility tests, namely disc diffusion assay. The first two pictures show the tests of this bug against 12 different antibiotics. So the clear zones formed around the antibiotic discs show that this bacteria was actually sensitive to the antibiotic. So this isolate was taken from the hospital water. But when we check the last two pictures, we see that no clear inhibition zones are formed, and actually this bacteria is resistant to all of the 12 antibiotics tested here, which makes it multi-drug resistance, and this bug was taken from a patient who had the Pseudomonas aeruginosa bacteremia. So we can say that none of these antibiotics will be helpful to treat this patient's infection. When looking through all this, we realized some links between the shower water strains and the strains found in patients' infections. So now we are trying to make those links. And my research showed that after running the shower water for a couple of minutes actually decreases the bacterial load. Given that this bacteria affects mainly immune-suppressed patients, let's say cancer patients, if you ever end up staying in the hospital with an underlying condition, make sure you run the shower water for at least 2 minutes to have safe water.
So we have all understood that this antimicrobial resistance is a serious global threat to the modern healthcare system, which can cause a severe impact on human health. The solution to tackle this issue includes the rational use of antibiotics and development of new drugs, but that's not very easy. At the same time, it is critical to develop a strategy that can kill bacteria instantly and prevent them from spreading, such as antimicrobial surfaces. Talking about these antimicrobial surfaces, one of the components that can be used to kill these bacteria on the surfaces is gold. Gold, we all have seen, is used in jewelry. But when we go at the nanoscale, basically 10 raised to power minus 9th of the meter, the properties of these gold particles changes drastically. So you all have seen gold, but these are the gold nanoparticles, and they exhibit different colors when they are in different sizes. So these are the particles that we use to immobilize onto the surfaces. These ultra small gold particles are known to exhibit antimicrobial activity, and they can ultimately kill the bacterial cells. These surfaces can be used in healthcare settings, in coatings. The thin film of the prepared antimicrobial surfaces can be coated onto the surgical and implantable devices to kill the bacterial cells on the spot. Apart from this, it can be incorporated onto the various fomites such as doorknobs, railings, clinical trays, keyboards, tables that are frequently touched by the number of people. So basically, rather than we can prevent the bacteria going directly to the patient on the before itself. So in this research, we have developed these gold particles that are attached onto these brushes, which are polymer chains, looks like it's in the hair brushes, to a surface by one, and the same fashion that bristles on a brush are connected. The method of the attachment will prevent the deattachment of gold, because we don't want gold to go away when it is being touched. And then these surfaces were also tested with two types of bacteria, E. coli and S. aureus. And what we see in that most of the bacteria was killed within an hour of the reaction. So these antimicrobial surfaces will kill the pathogens on the spot, thereby helping in preventing their growth and spread. This can be also a step forward in combating the problem of antimicrobial resistant germs.
So, let me ask you 3 questions, okay? Number 1, do you remember the last time that you had an antibiotic? Number 2, do you know if it was the right antibiotic for what infection you had? And number 3, do you know if you actually needed it or not? Now, research shows that in 7 out of 10 of those cases, the answer is no. You probably didn't need that antibiotic, or it probably wasn't the right one. In some countries, you can actually just go and buy antibiotics in your local equivalent of Tesco's or Sainsbury's or whatever. You walk into the shop and you say, let's have some penicillin, please. And they'll go, yeah, £1.50, please. You'll take that. What happens is, though, if you take that penicillin and it doesn't kill all of the bacteria, you get something like this happening. The bacteria that survive, they learn, they remember, they're like, hang on a minute, we know how to fight this now. So you get an image of what looks like a guzzling bacteria. What's really cool is as well that a lot of the drugs that we give to animals are actually the same as the ones we give to humans. So if you go to, say for instance, your vet and you get some drugs for your dog, and you go to your doctor and you get some drugs for yourself, some of those are actually identical exactly. So this is the way that AMR, antimicrobial resistance, can actually spread. So if you take a drug and you develop resistance in a human, in yourself, or if the same thing happens to animals, you can actually now pass these resistant bacteria backwards and forwards between different groups. So from animals to yourself, say for instance your dog gives you a nice sloppy wet kiss in the morning, but he's got some nasty things on his tongue. That can be antibiotic resistance, that can be spread to you. If you go into a local supermarket and you pick up some vegetables that have been contaminated, that's a way that antibiotic resistance can spread from the environment up to you. Now what's really cool about bacteria is they're tiny, tiny, tiny things. We can't see them. What they do is they have this genetic code called DNA. These are like the building blocks for life. When they develop resistance to an antibiotic, they can then take a little bit of this genetic code out of themselves, package it into something called a plasmid, and then hand it off to somebody else, or in this case, another bacteria. So this bacteria says, I made this, here's a plasmid. Gives it to this other bacteria takes it in. Now this bacteria has also made that plasmid and can spread it on to other people. So what my research is trying to do is figure out how these plasmids, how this resistance is spread between different types of bacteria in humans, in animals, and in the environment. So unfortunately I couldn't give you a sample. We take bacteria from poop. So I didn't think that would be very nice to bring into it today. But anyway, we take a very, very small stool sample, we take the bacteria from this, we dissolve it and we run it through a fancy machine. This gives us that genetic code, these building blocks for life. And what we can do is we can then search for the plasmids and then do some sort of trickery down the line and try and figure out, is it animals that are giving you the most resistance? Is it humans giving you the most resistance? With our limited resources, we can then design interventions which will specifically target wherever this resistance is coming from. And the goal downstream is to reduce the amount of antibiotics being used, reduce the amount of resistance being propagated.
What do you wish people knew about AMR?
There are alternative therapies available which don't need to be treated with antibiotics. A cough, a cold is caused by a virus. No antibiotics will help treat viral infections.
Yeah, AMR is not going away, and it's set to be far worse than we've seen this year. The COVID vaccines have shown us that we as a global community can respond successfully to drastic healthcare crises if we bestow enough time and money. So why aren't we lavishing that sort of attention and money on a worse problem?
The most important thing is awareness of this issue and how it can be tackled by making small changes in life, such as the use of antibiotics.
Always get advice from a doctor. If you have an infection that is green or pussy, never try to treat an infection yourself, and never take antibiotics prescribed to another person. Every diagnosis and prescription is personal to yourself.
You, all of you, be careful about the usage of antimicrobials. And if each of you tells other people you come into contact with what we have said today, that will make a difference.
We all have a part to play in reducing AMR. AMR does not respect boundaries between people, communities, or countries. Only by everyone doing their bit, we will make any headway.
What would you like to happen to change our relationship with AMR?
So for one thing, scientists are really good about publishing their results in medical journals, but medical journals are not accessible to everybody. So actually making a partnership between people that work in the lab and people that can better disseminate that research might be a good way of getting our information out there in an accessible way.
I would like to see the change in people's understanding of AMR.
We have to look at AMR as a solvable problem that requires the appropriate investment to overcome, and then we just need to make that happen.
It's not a future problem, it's happening right now. Don't overuse antibiotics, and if you must use them responsibly.
Thank you guys so much. That was really amazing. I have some big thank yous to say. So most of the words, in fact all of them, have been put together from surveys of scientists, some of whom are here today, who are talking about their own work, but also people who are involved in this wider project as part of Precision AMR, who have given their thoughts and their time on what antimicrobial resistance is and the things that they felt that they needed you guys to hear and start to have that conversation about. So massive thank you to everybody that's been involved. I've got one quick question, because we're almost out of time for everybody, that would be really interesting to hear is, you guys are from slightly different worlds, think of kind of creative worlds and scientific worlds as being very different. Has being involved in this actually made you think differently about either antimicrobial resistance or how you have conversations about it? And is there any advice that you throw out there to scientists and all of us who are going to be sitting at a pub in a non-pandemic world at some point talking about this? Is there anything that you would like us to be talking about outside of here?
Yeah, hugely. I've learned so much today, and so that piece that I did, that was my personal experience, but you know, that's so simplistic about how I understood or misunderstood what was happening to me in hospital. And just everything that I've heard today about, you know, UTI infections. I was just saying to Hal, my mum's currently on her 4th course of antibiotics for UTI. No one has said to her any of this stuff, and it's not hard. I think probably all of us, the actors, are a bit like, oh, it's going to be, I won't understand this. But maybe you're just all brilliant at explaining it, but it seems explainable and understandable. And we should all know this as a matter of course, as a public health we should all know this, shouldn't we? Everything you've talked about today. So, yeah, I don't know where I came with that, but
I think that's brilliant. I think if there's one thing that this entire weekend is about encouraging people to talk to one another. And this is only the start, so I'm hoping that you'll join us for the rest of the events over the weekend and on Sunday for our Never Explained comedy show, which will talk about AMR with a bit of comedy in a very different way. And we're hoping that you will take those conversations that you've started with us today and continue to have them not only over the weekend, but when we get back to real life and pubs and restaurants and talking to everybody. So thank you very much. And thank you all you guys and everyone who's been involved. It's great.
thank you.
Good night, guys.